Alright, so if I plug everything in, if I got my X now, I plug it in, I'm going to get 0.865 molarity. Then plug X into right here. I'm going to get 0.135 is just my X, and plug X into here. I'm going to get 0.135 molarity. Alright. So if I know my overall reaction rate, if I know what my equilibrium constant is, I should be able to know my concentrations at equilibrium. So this question asks, what would be the effect of each of the following on the equilibrium involving the synthesis of methanol? And explain. Right. So if we remove methanol, remove methanol from the chemical equation, equilibrium is going to shift to the right because it wants to compensate for the loss of the product. So if we remove this, the equilibrium will have more reactants than products. The equilibrium will have more reactants than products. So to equal that out, it wants to increase the products, so the concentration will equal out. So it will shift to the right to increase the amount of products. If it is an increase in pressure, the equilibrium is going to shift to the right because it will go to the side with less molecules to alleviate the pressure. I'm guessing pressure is like force over amount of space or over area. So if there's less molecules, then that pressure will kind of be decreased. So it will go to that side with less molecules. That's why it will shift to the right if you increase pressure. If you lower the concentration of the hydrogen gas, equilibrium will shift to the left because it will have more products than reactants, and then it's not balanced. So to balance it out, it will try to gain more reactants, so it will shift to the left. If you add a catalyst, it should have no effect on equilibrium, since a catalyst is consumed in a reaction and only lowers the activation energy, which speeds up the reaction rate. However, if you add it, it should have no effect on the equilibrium because it should just speed up the rate of the reaction. It should just speed up the reaction rate, and that should be all. For this problem, if 0.050 milliliters of 6.0 molar hydrochloric acid is added to 400 milliliters of 10 to the power of -5 molar hydrochloric acid, what is the resultant pH? Key vocab to know is pH is -log base 10 of hydronium concentration, and molarity is moles over 1 liter. Right? So let's go ahead and solve this problem. We have 0.050 milliliters of 6.0 molar of hydrochloric acid.